Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you. Welcome back to another session of Operating System Mastering Gate Concepts for 2023. And today we are going to start the classical problems of synchronization, which is very important. And most of the students, they suffer to understand these classical problems of synchronization. And the first problem we are going to discuss today is a reader's writer's problem and its solution as well. And on the basis of this, we are going to solve some questions also. So guys, do like the session, share as much as you can, and also subscribe to BYJU'S Exam Prep YouTube channel so that you don't miss any notifications related to our sessions for computer science. Yes guys, keep liking. Good evening all of you. Mark your presence in the comment section and let us know who has joined. Yes guys, good evening all of you. So today we are going to start this reader's writer's problem. Hi Yuvraj, good evening, welcome. Yes guys, do subscribe to BYJU'S Exam Prep YouTube channel, don't miss that, and also press the bell icon so that you don't miss any notification. So before starting, let me introduce myself. My name is Anshul Sharma. I have 2+ years of experience, and in GATE 2020 I have secured All India rank 294, cleared ISRO and NILET exams, mentored more than 1,000 students as of now, and these are my area of expertise: operating system, digital logic, computer organization, and compiler design. Welcome all of you. Yes guys, and one more thing I would like to discuss here is, if you want to get the PDF of my classes and if you need any guidance related to your preparation for GATE 2023 or 2024 or for any computer science exam, then you are most welcome. You can reach out to me through this Telegram group and I will definitely help you out. Also, if you have any doubt, then also you can reach out to this. This is the link. You can search on the Telegram and you will be getting, and you can join this for all my PDFs for my YouTube classes, doubt clearances, and the guidance. So without waiting guys, let's start. Guys, do like the session, share with your friends as much as you can. One more thing I would like to mention here is, so we have started this mastering concepts for GATE 2023. That is a free online YouTube course. So here we will be providing the entire every concept, the most important concepts and the most difficult concepts, right? So this is the schedule. You can see for mechanical engineering, for civil, for computer science, for EE and ECE, this is the schedule, and on these days we are going to have the classes. So don't miss any classes, okay, and get the benefit of this free online course that we have started on YouTube. Yes guys, so without waiting, let's start and talk about a reader's writer's problem. So here why we are calling it as problem? What is the reason behind this that we are calling reader writer is a problem? So as we know, why do we need synchronization? So that we can avoid inconsistency, right? That means if one process is writing, right, and another process is suppose reading the data, in that case we may have inconsistency, that other process may read the incorrect data. That is a possibility. Similarly, if we have two processes and one process is writing and at the same time another process is also writing or updating the value, in that case also we can have the inconsistency in the data. So this thing is based on reader's writer's problem. So as you can see, we have 4 cases here in case of reader's writers. First case is when we have the reader in the critical section and we have the writer also, then yes, it is a problem because the reader is reading the critical section. That means the common shared resource where the writer is updating the value or writing something. So definitely it will cause inconsistency. Similarly, we have the next case also where we have the writer first and then we have the reader. So that will also create the problem here. The third problem we have is when we have a writer already present in the critical section and another writer arrives, in that case also it may cause problem. Hi Ikra, good evening. Good evening Saubhagya, hello. Yes, guys, do like the session, share with your friends as much as you can. Now, the fourth case we have is when we have already one reader present in the critical section and another reader arrives. But that is not a problem here. Why? Because both the readers are reading the value, they are not updating it. So if they are just reading the value is going to be same, right? It is not getting updated. So this is not a problem for us. So these three are the cases for which we need to find some solution. We need to find some solution so that we can avoid this kind of problem, so that if we are having a reader, then we are not going to allow the writer to access the critical section. If we are having a writer, then we are not going to allow the reader to access the critical section. And if we have already one writer, then we are not going to allow another writer to access the critical section at the same time. Is it clear? Good evening Aditya. Welcome all of you. So guys, let's see the code for a reader writer problem. So this is the code. Now, before explaining this code and how it works, let me tell you one thing. This is the code you have for writer, right? This is the code you have for a reader. That means this void reader will execute this one. You can say this is a kind of entry section. So I hope you know this, the template of synchronization. First we have the entry section, then we have the critical section, and then we have the exit section. So here from this point onwards, we have the entry section of the reader, this database, that is, you can say, the critical section, and then you have this one as the exit section of the reader. Exit section of the reader, and this is the code we have for writer. Obviously this is going to be the entry section, then this we have the critical section, and then the exit section. Now let's understand it and let's see how it works, how it is avoiding, how it is finding the solution for those three problems. So let me write one by one here. We have the first case where we have one reader and then writer arrives. We have the second case when we have the writer already present in the critical section and one reader arrives. And the third case, that is, a writer is already there and another writer wants to access the critical section. So for these things, for these three cases, we are going to find the solution for this reader writer problem. Yes Aditya sir, आप complete prepare करवाएंगे ना यहाँ पे? Definitely. First of all, we have started with operating system, and I have taken the most difficult part, the most important part that you can definitely expect in the GATE exam, which is synchronization. So I'm covering the entire synchronization here. After this one, we are going to have another subject that is maybe programming in C, and then we are going to cover all the important concepts, and some other faculty, maybe Satya sir or Anil Prasad sir, will be covering that. Most probably Satya sir will be covering that, right? So similarly, this plan is going to continue throughout the year, and we are going to cover different concepts from all the subjects. Okay, so just keep learning here, keep learning from these free online course that we have started on YouTube. That will definitely give you the benefit, and your concepts will get clear. That will really help you in GATE 2023 and 2024. GATE result out, I think not yet, right? Not yet. Maybe you can check the website later on. Okay. Most probably they will be releasing the result tomorrow or maybe midnight, right? Let's see. But first, our priority is to understand this thing. Then later on we can talk about the result. Okay. But it is not out yet. It is not out yet. Now, the first case, reader writer case. So when we have one reader here, now carefully see, int RC is equal to 0. Now what this RC indicates? This is indicating that readers count. Readers count. So here it is counting, this is an integer, it is counting how many readers is present in the critical section. So on the basis of that, we are maintaining one count for the number of readers arriving. So let's say we have one reader here. Let's talk about the first case. RC is equal to 0. Fine. Now we have two binary semaphores here. One is your mutex, other one is your DB. and the initial value for this binary semaphores is 1. Initial value for this binary semaphore is 1 here. Clear? Now carefully see, this reader is going to execute this code, void reader. Now while true, down of mutex, so this is going to make it as 0 because it is a binary semaphore. Already we have studied what is semaphores, how it works. So it is performing down operation, that means wait operation, or you can say P operation. It is decrementing the value of mutex by 1. Clear? Now it is going to update it. RC is equal to RC plus 1. Why? Because one reader has arrived, so it has to update the count of the reader. Earlier it is 0, that means there is no reader present. Now RC is equal to RC plus 1, so we are going to update the value of reader count. One reader has arrived. Is it clear so far? Is it clear so far? Now carefully see, if RC is equal to 1, then down of DB. Now if you have only one reader present, in that case down of DB you have to perform. Now what is the reason behind this, why we are performing down of DB? Because our problem is, if we have the reader, we don't want to allow the writer to access the critical section. So that is why if we have one reader already present in the critical section, or when reader arrives, in that case I don't want my writer to access this critical section. So that is why I'm performing down of DB, because if I perform down of DB, RC is equal to 1, yes, RC is equal to 1, I will be performing down of DB, it is 0 now. So in this case, as I perform down of DB, let's say one writer is wants to access this code. So let's say writer 1 arrived. What will happen? While of true, down of DB. Already the value of DB is 0. It is a binary semaphore. In that case, the writer will get stuck here. It will get blocked here. Is it clear so far? The writer will get blocked here. So in this case, the writer will not be able to proceed further. And that's what we want. We want that if one reader is already present in the critical section, or one reader has arrived, we don't want the writer to access the critical section at the same time. So this is what we are doing here. Clear? Now down of DB we have performed. Fine. Let's write here writer 1 is present here. Now it is blocked here because it is not able to proceed. Already DB value is 0. Up of mutex. Now understand this. Why we are performing up of mutex? What is the reason behind this? Because if one reader has arrived, now if other readers also wants to access the critical section, then there is no problem. We can have more than one readers present in the critical section at the same time. So that is why we are performing up of mutex, so that other readers can also arrive. So let's see here, we were talking about a reader 1 here. So up of mutex, make it 1, and let's say we can write reader 1 is present here. Clear? Reader 1 is present here. So can I say this, we have found out the solution for this first case? Yes or no? When reader writer is there. Is it clear so far? Any doubt, anyone? Because when reader is already there, then writer is not allowed to access the critical section. DB means database, you can say, or critical section, shared resource basically. So for first case it is done, right? Now let's talk about the second case. When we have one writer already present in the critical section and then one reader arrives. Now carefully see. Let me just erase this so that you can understand it clearly. Okay, we are considering the second case now. Fine. Right. Now let's see this. Let's say one writer arrives. So writer is going to execute this code while true, down of DB. So it is going to make it 0. Right? That means writer 1 is present in the critical section. It is accessing the critical section. Now let's say at the same time a reader arrives. What will happen? RC is equal to 0. Readers count is equal to 0. Fine. While of true, down of mutex. Okay, let's make it 0. Now RC is equal to RC plus 1. Yes, we have to increment the readers count. Now if carefully see, if RC is equal to 1, Now if one reader has arrived, that means RC count is 1. In that case, down of DB. DB value is already 0, which is a binary semaphore. Now here this reader 1 will get blocked. Because RC value is equal to 1, then down of DB, it will not be able to proceed further. Because already DB value is 0, that means writer is already there. Is it clear to all of you so far? If you have any doubt here, please ask. Now we are going to consider more cases, more possible combinations. Let's see here. Let's say one more reader arrives. Let's say R2. So it will also execute this thing, while of true, down of mutex. Mutex value is already 0. That means here R2 will get blocked, R3 will get blocked, all other readers will get blocked. It will not be able to increment readers count value. That is why it is down of mutex here. Now let's say writer. So you can see here we have solved this problem. When already one writer is present in the critical section, we are not allowing reader to access the critical section. That means second case is also solved. Now if you have any doubt so far, please ask. Anyone having any doubt, please ask in this. So I will make this code very easy for you. If you just look at it once, you will understand each and everything here. Okay, I'm not just executing this code, I'm taking all the possibilities here so that you can understand each and every aspect of this problem. Yes, and I'm how to access PDF. So after completing this session, I will be sharing the PDF in my Telegram group. So at the end, in the starting also have shared the link of the Telegram group. You can join that. At the end also, I will be sharing the link again. You can join and you can get the PDF of all my YouTube classes. Now carefully see here. Come back to this one. Let's say a writer completes its execution and now it is performing up of DB. Up of DB, so it is going to make it 1. Up of DB. Now carefully see this. Reader 1 will perform this. If RC is equal to 1, then down of DB. So now it is going to wake it up. So R1, reader 1 will perform down of DB. Yes, make it 0. Now reader 1 up of mutex, because if one reader is allowed to access the critical section, at the same time it will allow other readers also to access the critical section, because reader is not having a problem here, right? So it will make mutex 1 and now R1 is present here. Similarly, R2 will perform down of mutex, make it 0. RC is equal to RC plus 1. So it is going to increment the value of reader count because second reader is arriving. Then if RC is equal to 1, no, it is not true. So we are not going to perform down of DB, right? So in that case, up of mutex, because we want to allow other readers also to access it. So R2 is present here, right? Similarly, R3 will arrive and it will also do the same thing. So we are having as many readers as we want. So let's say 3 readers are present in the critical section here. Now let me just erase this thing now, because writer is gone, right? Now, so this problem is also solved. Is it clear? This problem is also solved. Now carefully say this. Let's talk about this third case. When already one writer is there and you are having another writer. So let's see this carefully. Writer will perform down of DB. This is the simplest case you can have. Down of DB, let's say initial value is 1, it will perform 0 and writer 1 is present here. Let's say writer 2 arrives, down of DB, already DB value is 0, it is a binary semaphore. So writer 2 will not be able to perform down operation, it will get blocked here. That means at a time you can have just one writer present in the critical section. You cannot have more than one writer. Is it clear, everyone? Any doubt you have? So all 3 cases are resolved. Now we need to understand this exit section code also. Why it is written, why we need that. Now carefully see this. Let's consider this fourth case when we have readers. Obviously this is not a problem for us. We are not going to have any inconsistency, but As we are having multiple readers, then we need to maintain the read count also. Now carefully understand this case. This is very important, guys, so carefully see this and pay attention. Okay, fine. Now okay, this is going to be 3. So this is going to be 3. So we have 3 readers now. Carefully see this. We have 3 readers now. Let's say R1 completes its execution of critical section, and now you have the statement. This is the exit section, so you have down of mutex. Now if I ask you why we are having down of mutex here, right? Because we are not having any problem, right? Why it is, if any other reader wants to access the critical section, but why it is performing down of mutex? If it is performing down of mutex, in that case other reader will not be able to come further, yes or no? But the reason behind it performing down of mutex is that it wants to perform this RC is equal to RC minus 1 without any interruption. That means, let's say if this reader 1 perform down of mutex, it is going to make it 0, right? Why it is making it 0? Because it does not want any other reader to perform down of mutex and to increment the read count, because at the same time it is going to decrement the value of read count. So there will be inconsistency in case of read count value. Is it clear? If R1 is performing RC is equal to RC minus 1, decrement the value of read count, it does not want at the same time to perform RC is equal to RC plus 1 if any other reader is arriving. That is why it is performing down of mutex, so that if other reader arrives, let's say R4, in that case it will get blocked here. It will not be able to perform RC is equal to RC plus 1 till we signal the value of mutex, till we up the value of mutex. This is the reason here. Is it clear to all of you so far? Now this RC is equal to RC minus 1 we are going to perform. Fine. That means now there are 2 readers present. Okay. If RC is equal to 0, so the meaning of this statement is, if there are no readers now, RC is equal to 0, then you have to up the DB, so that we can have, if there is no reader present in the critical section, then you can allow any other writer to access the critical section. That's why if RC is equal to 0, so it is checking, do we have any other reader present in the critical section? If yes, then don't perform this. But if you are not having any other reader, then perform up of DB, so that we can have the writer, we can allow the writers to access the critical section. Is it clear? Now carefully see this. So R1 performs RC is equal to RC minus 1. Now 2 readers you have. RC is equal to 0. No, it is 2. So up of mutex. Now make it 1. Now if any other reader wants to come in the critical section, it can perform down of mutex. Clear? So this is the reason why we are having this down of mutex statement here, because we don't want inconsistency in the value of read count here. Okay. Similarly, R1 is gone. Now we have R2. It will also perform down of mutex. Fine. Make it 0. RC is equal to RC minus 1. Make the read count as 1. RC is equal to 0. No, it is 1. So up of mutex. Process the data. So R2 is also gone. Now we have R3. So R3 down of mutex. Make it 0. RC is equal to RC minus 1. Make it 0. That means there are no readers present here. 0 readers. So if RC is equal to 0, then up of DB. So earlier it was 0. So make it up. Up of mutex. Make it 1. So finally, again, we are having the values of binary semaphores as 1, which we have initially. Okay. Then we are going to process the data. Is it clear? This problem and its solution, is it clear to all of you? So we have these 3 problems. We have arranged the reader and writer in such a way, and we have used the binary semaphores in such a way so that we can avoid this problem. We are not going to have these 3 problems here in this case. This is the solution of readers writers problem, and this is never a problem for us. Clear? Now if you have any doubt here in any of the case, please ask. I will explain again if you have any doubt. And guys, keep liking the session if you haven't liked it yet. All clear so far? So you are not going to get the better explanation than this, I can tell you that. Anywhere, any lecture you can see, you are not going to get better explanation than this. Here I have not just executed the code, I have explained you why we are having these statements here, why we are having down of mutex, up of db, up of mutex, because that is important here. You need to understand when we are having down of mutex, when we are having up of mutex. Similarly, when we are performing down of mutex, up of db, that is important here to understand. Okay, code everybody can execute, even you can easily execute, but why we are having down and up operations and where we have to keep those operations, that is important in readers writers solution. Okay, now I have one question for you, and this is the question, and you have to answer this. This is the previous year question. Now you have to answer this question. So here you have to just find the values of S1, S2, S3, S4. Already the code is given to you in short. You just have to find what should be the value of S1. So here you have to find the value of S1, S2, S3 and S4. So if you have understood the concept clearly, you can easily answer this question. So I'm giving you 1 to 2 minutes. Read the question carefully and then try to answer this. I hope the question is visible to all of you. So this question is directly based on readers writers problem and its solution. Yes guys, what should be the answer? And guys, don't forget to subscribe BYJU'S Exam Prep YouTube channel, because throughout your preparation we are going to conduct multiple sessions, hundreds of sessions we are going to conduct, so that you can prepare well. And this is a free online course, YouTube course, and you are never going to get this kind of course that we are providing here. Yuvraj is saying option C should be correct. Okay. And Naim is saying option A should be correct. Yes, anyone else getting the answer? Yes guys, I want a response from each of you, those who have understood the concept here. Doesn't matter you are giving correct or incorrect answer. The important thing is you are trying to understand the question, because in GATE you can perform well only if you understand the question properly. If you can't understand, if you can't read the question properly, if you can't get the meaning out of it, you will not be able to perform well in the GATE exam. I'm telling you this. So first try to understand the question and then think about what can be the values. Options are given to you. Try to execute all the options. Take option A, think about it. If read count is 1, then what should be the value of S1? If read count is 1, that means already one reader is there. So should we allow any writer to access the critical section? No. Then what to do if we don't want to allow any other writer to access the critical section? So in that case we have to perform weight of WRT here, or you can say DB. In this question it is given WRT, so you have to perform weight of WRT, so that if one reader is already present in the critical section, you should not allow any other writer to access the critical section. This is the approach, this is the thinking you have to apply in these type of questions. Okay, so if you see here, let me read the question for you. Synchronization in the classical readers and writers problem can be achieved through use of semaphores. In the following incomplete code for readers writers problem, two binary semaphores mutex and WRT are used to obtain synchronization. So in the explanation, in the concept, we had mutex and DB. Here they are saying mutex and WRT, right? Now what should be the values of S1, S2, S3, S4 in that order are, you have to find it out. Carefully read the code first. Weight of WRT, writing is performed, signal of WRT. That means these three statements belong to writers, right? Writer is going to execute these three set of statements here, and you can clearly see that writer is using this binary semaphore, which is WRT. Fine. Now weight of mutex, read count is equal to read count plus 1. So this code, it is going to execute by your readers. So it is going to first perform weight of mutex. If read, so it is going to increment the read count. Let's say read count initial value is 0. So it is going to increment it by 1. Fine. If read count is 1, now if read count is 1, that means already one reader is present in the critical section. In that case, what to do? If one reader is present, I don't have any problem with other readers, right? But I have the problem with other writers. So I won't allow other writers to access the critical section. So that is why this S1 should be what? This S1 should be weight of WRT. I will be performing down operation on WRT so that if writer tries to execute, it will get blocked here. Weight of WRT, it will get blocked here. Is it clear to all of you? This is the reasoning, this is the approach you have to apply to answer synchronization questions correctly. Now carefully see this. So we have performed weight of WRT. Now S2. Now you think like this. If one reader is already there, I should allow other readers also to access the critical section, because I have performed a weight of mutex. Then what to do? If I want to allow other readers also, in that case I will be performing signal of mutex, so that I should not stop other readers to access the critical section. Yes, exactly. So now reading is performed, no problem at all. S3, now reading is performed. Now what should be the value of S3? So here as you can see, now I have to decrement the count value, read count value. If I want to decrement the read count value, I don't want at the same time to increment the read count value by other readers. So in that case, I will block the other readers to come into the critical section, right? So that is why I'm going to perform a weight of mutex here, because I don't want inconsistency in a read count value. When one reader is decrementing the value of read count, I don't want other reader to increment at the same time. Problem will be there, right? So that is why weight of mutex we are going to perform here. And then obviously if read count is equal to 0, that means there is no reader present. There are no readers present in the critical section. Then we should not stop writers to access the critical section, yes or no? So that is why this S4 would be what? Signal of WRT. This is going to be your answer. S1 value is weight of WRT. S2 value is signal of mutex. S3 value is a weight of mutex, and S4 value is a signal of WRT. This is the correct answer for this question. Now if you have any doubt here, please ask, guys. Any doubt, anyone? समझ में आ गया? Clear होगी? Now you will never forget the explanation of this reader writer. I can tell you that. If you have listened carefully with full attention, you will never ever forget how this code works, how this reader writer's solution works. I can definitely tell you this. You just have to see this code again and again, and then just after seeing it, you can analyze, okay, this is the thing, how it is working. Clear? Fine. So let's solve the next question. The next question is not based on readers writers problem, but yes, it is based on a synchronization only. So try to answer this question also. Question number 2. You have two processes here, P1 and P2, accessing the shared variables x and y. Okay, I'm sorry. Accessing the shared variables x and y, P1, P2, two processes. They are using two binary semaphores Sx and Sy respectively, both initialized to 1. Both semaphores are initialized to 1 here. P and V denote the usual semaphore operators, that means down and up or wait or signal, right? And this is what we know already, what it is going to perform. In order to avoid a deadlock, now we don't want a deadlock. If I don't want deadlock, what should be the correct operators? L1, L2, L3 and L4 are respectively. What do we have to fill here in L1, L2, L3, L4 so that we can avoid the possibility of deadlock here? Yes, what should be the answer, guys? Everyone. How we can avoid the deadlock here? How we can avoid deadlock here? Yuvraj is saying D should be the answer. Okay. Anyone else getting the answer for this question? Question number 2. And guys, let me know, maza aa raha hai, nahi aa raha hai? Are you getting the concepts correctly or not? Because the most important thing is enjoying the class. If you can enjoy the class, learning will be easy for you. Even for faculties as well. If they enjoy while teaching, then they will give you the best content. Similarly, a student has to also enjoy while learning. Okay, enjoying means paying full attention, right? But with a relaxed mind. Okay, full focus should be there. Yes, so let's see here how we can avoid the deadlock. Let's take option by option. Option 1, P of S of Y. Fine. L1 is your P of S of Y. P of S of X. L2, P of S of X. P3 is P of S of X. And fourth one is P of S of Y. Fine. Both semaphores are initialized to 1, right? That means initial value is 1 here. So let me write here Sx is equal to 1, Sy is equal to 1. Both semaphores are having initial value 1. Let's say P1 executes. P of Sy, fine, it performs 0. Let's say it got preempted. Let's say P2 arrives, P of Sx decrements the value. Now let's say P of Sy. What will happen? Blocked here. Because it will not be able to perform down operation on Sy because already the value is 0. Come back to P0, P1. P of Sx, already the value is 0, blocked here. So P1 is blocked here and P2 is blocked here. None of the process is able to make the progress. So no deadlock. So deadlock will be there, right? Deadlock is there. That is why none of the process is able to execute further. Clear? But we want to avoid a deadlock. So that's why option A is incorrect here. Option A is incorrect here. Now let's take option B. Let's take option B now. P of Sx, okay, P of Sx, it is there. Then we have P of Sy, then we have P of Sy, P of Sx. Now carefully see this. This is P of Sx, P of Sy, P of Sy and P of Sx. Fine. Again, let's say initial value of Sx and Sy is 1. That is given in the question, right? So this is 1, this is 1. P of Sx 0. Let's say it got preempted here. P2 process arrives. P of Sy, it is performing down on Sy. Make it 0. P of Sx, again it will get blocked. So P2 will get blocked here because already the value of Sx is 0. It will not be able to decrement it further. What about P of Sy? It will get blocked here because Sy value is 0. That means in this case also none of the process is able to make the progress. So deadlock is definitely there. Definitely the possibility here. So option B is also incorrect here. Option B is also incorrect here. Let's talk about option D now. P of Sx, P of Sx, P of Sy, P of Sy. Fine. Now carefully say this. This is a P of Sx, P of Sy, P of Sy. This is clearly visible. P of Sx, make it 0, fine. P of Sy, make it 0, fine. If already it has done P of Sy, how it will perform it again? It will get blocked here, right? Because Sy value is already 0. Similarly here, it will get blocked here. Sx value is already 0. Option C is also incorrect. Option C is also incorrect. Now, what about option D? What about option D? P of Sx, P of Sy, P of Sy. And here you have P of Sx. This is correct. This is correct. Why? Because both processes are first decrementing the value of Sx semaphore. So that is why either P1 is going to decrement it first or P2 is going to decrement it first. Let's say P1 decremented. So it will make it 0, fine. Now let's say it got preempted, P2 arrives, P of Sx. It will get blocked here. It will get blocked here because Sx value is already 0. Let's come back to P1. Sy. Yes, it will perform. It will decrement the value, make it 0. So P1 will be able to access. That means there is no deadlock. There is no possibility of deadlock in option D. There is no possibility of deadlock in option D here. Is it clear, everyone? If you have any doubt here, please ask. Let's solve this question now. Let's solve this question now. Yes, guys, what should be the answer? And guys, keep liking the session if you haven't liked it yet, and also subscribe to BYJU'S Exam Prep YouTube channel so that you don't miss any notifications of the computer science classes that mastering concepts for GATE 2023 that we have started. Free online course, the best course you will get anywhere. Try to solve this question. Here you have 3 semaphores. S0 is 1, S1 is 0, S2 is 0. Question is, how many times will process P0 will print 0 here? So you have 3 concurrent processes, P0, P1, P2. You have 3 semaphores here. You just have to find how many times it will print 0, P0 process. Yes, everyone try to solve this question. One thing you need to pay attention here is that P0 process is having this while loop. That means it can execute again and again. But P1 process and P2 process, they are not having any while loop. That means they can execute only once. P1 and P2 process can execute only once because it is not present in while of true. P0 is present in while of true. It can execute as many times as possible. Fine. Now let's try to answer this question, everyone. What do you think? How many times it will print 0, P0 process? Yes, everyone try to answer this question. I hope it is visible. Question is visible to all of you. And guys, in the next class we will be discussing other classical problem of synchronization, that is producer consumer problem and its solution. So that class is also going to be very important, and that class is on, I think, 20th, okay, because we have the festival of Holi. So that is why that class will be conducted on 20th of March. Yes, okay, and I am saying exactly twice. Fine. Anyone else getting the answer? Let's see here. Let's see here. Let me write here. S0 value initially it is 1. S1 value initially it is 0, and S2 value initially it is 0. Fine. Let's say we start with P0. While of true, wait on S0, decrements the value of S0, make it 0, fine. So what we are doing, we have started with P0 process. Print 0, let me write the output here, print 0, fine. Now release of S1, you already know this, that we have to start with P0 because S1 value 0, S2 value 0, we cannot start with P1 or P2 because they are performing wait operation on S1, wait operation on S2. We have to start with P0. Release S1, that means we are performing, release means we are performing signal operation here. So release of S1, so make it 1 here, fine. Release of S2, make it 1 here. So far we have printed it once. Now carefully see this. Let's say process P1 executes, wait of S1, okay, make it 0, wait operation we are performing, down operation. Release S0, release S0, so we are going to make it 1. Let's say after P1 we executed P2 or P2 got executed, wait of S2, so make it 0. Release of S0, already it is up, right, because it is a binary semaphore, we cannot further increment it, it is going to be 1 only, right. That means process P1 and process P2 execution is done. They cannot execute again because they are not present in while loop. Okay, now come back to P0 process. S0 value is 1 here, wait of S0, okay, make it 0, print 0, fine. Release S1 कर देते हैं, release S2, done. What else? खत्म. So it is printing, in this case it is printing twice. In this case it is printing the 0 twice. But is it the only case possible here? What do you think? Is it the only case possible here? Let's analyze the other possibility also. Let's say S0 value initially 1, S1 value initially 0, S2 value initially 0. Fine. We started with the P0 process because we have to start, and here we are writing the output. P0 executes while of true, wait of S0, make it 0, fine. Print 0, output is 0 so far. Release S1, make it 1. Release S2, make it 1. Fine. Let's say P1 executed now, because P0 cannot execute now as of now because S0 value is 0. Let's say P1 executed, wait of S1. Wait of S1, that means make it 0. Release of S0, make it 1. In this case, first P0 executed, then P1, then P2. In this case, I am assuming first P0 executed, then P1, and now I am executing P0 again. So if P0 executes again, wait of S0, make it 0. Print 0, one more 0 here. Release S1, fine. Release S2, already it is 1. Still you can overwrite the value because it is a binary semaphore. You can have just two values, either 0 or 1. Fine. So now P1 execution is done. It cannot execute again. It can execute only once. Now P2, still it has not executed. Now we will be executing P2 here. Wait on S2, make it 0. Release of S0, make it 1. Come back to P0, wait of S0, make it 0. Print 0, release of S1, release of S2, make it 1 again, done. Now how many times it is printing 0? 3 times it is printing 0. So what should be the answer? We have one case where it is printing twice. We have the case where it is printing thrice. So at least twice, we can say so. Exactly twice? No. It is printing 3 times also. Exactly thrice? No. Exactly once? This is a big no. Option A is the correct answer. Option A is the correct answer for this question. In this one, the order is P0, P1, P0, P2. In this case, the order is P0, P1 and P2. Mayank Arora, have you joined just now? Let me know once. Have you joined just now or from the beginning of this question? Any other doubt? If you have any other doubt, please ask. The important thing here to understand is it can execute only once. Similarly, this can also execute only once because they are not present in while loop. While of true, that means it is going to execute again and again if the binary semaphore value is 1. If the binary semaphore value is 1. You have joined just now, that is why you are finding it difficult to understand. You can just rewatch from the beginning and you will be able to understand everything in this question. Okay, just from this beginning of the question. Fine. Let's solve this question now. Question number 4. Again, this is one of the previous year question based on synchronization. And this is going to be the last question of today's class. This is going to be the last question of today's class. So guys, here you have to find the maximum value. Maximum value would be y. Maximum value of d, that is possible here, and minimum value of d, that is possible here after concurrent execution of P1, P2 and P3. And then you have to find the difference of those maximum values, maximum value minus minimum value. What should be the answer here? So let me tell you one thing. This is the arithmetic operation. This is also arithmetic operation. This is also arithmetic operation. Arithmetic operations are not atomic. Arithmetic operations are not atomic. They are divisible. That means let me write d is equal to d plus 20. This arithmetic operations, if you see at the assembly level code, you will find it out like this: load d comma r0. That means you are loading the value of d into r0. Then you are performing add operation. R0 has 20. You are adding the value of r0 with 20, and then you are storing the value of r0 back to d. This is going to be the code at assembly level. But why they are not atomic? Because we don't execute it like this. We execute the assembly level instructions. We always internally, it will be executed like this. First we are going to perform load operation. D value will be loaded into the general purpose register of that process. Then we are going to add r0 to 20. Then we are going to store the final value of r0 to d. This is how we perform arithmetic operations. In computer organization also we talk about these things. Okay. Yes, so I have given you the hint. Now try to find out what should be the maximum value here. Maximum value, that means y, and what can be the minimum value, that is x here. Yes, anyone getting the answer? Yuvraj is saying 80 should be the answer. Okay. Anyone else? Let's see here. The processes are executed on a uniprocessor. That means you have just one processor. You don't have multiple processors running a time shared operating system. If the minimum and maximum possible values of d after the three processes have completed execution are x and y respectively, then the values of y minus x is. Then the value of y minus x is what? Now carefully understand here. Let's talk about maximum value first. If I want to find out the maximum value, the possible case would be initial value, as you can see, it is 100. Initial value is 100. Okay, fine. D is 100. Let's say P1 executed it completely. Make it 120 because you are adding 20. Fine. That means P1 has executed all these three assembly level instructions. D value is 120 now. Let's say P3 executed now. After P1 we are executing P3 because it is performing addition. We want to find out the maximum value. So what it does, before it stores the value back to D, right? Let me write here. Let's say it is having general purpose register R3. In R3 we have the value 120, it added it, so it makes it 130, but just before it is going to store the value back to the D, let's say it got preempted. Now execute P2 completely. So as of now the value of D is 120, not 130, because R3 is having 130. Still we have not stored the value of R3 into D. So P2 is going to read the value of D as 120 minus 50. Let's say perform completely. 120 minus 50, you are going to get 70. But then again back to P3, it is going to store the final value of R3 into D. So final value of R3 will be updated by 130. So maximum value possible here is 130. Maximum value possible here is 130. Guys, do like the session, because actually it motivates me to give my whole energy to this session so that I can explain you the concepts in a best manner possible. And also subscribe to BYJU'S Exam Prep YouTube channel. Right, now let's talk about the minimum value. So one case is done. Again, let's consider initial value is 100. We need to find the minimum value here. So carefully see. Let's execute what do you do? Let's execute P2 first. Because we need to find minimum value. So first perform the subtraction. 100 initial value, let me write here. Initial value is 100. You perform minus 50, but just before storing the value back to D, let's say you are using R2 register here. R2 read the value of D as 100. It performs the subtraction. So it makes it 50 here. Just before it was about to store the value of R2 back to D, it got preempted. Now what will happen? Let's say P1 executed completely. So P1 will read the value of D as 100. It will perform 120. Let's say P3 execute completely. P3 will read the value of D as 120, perform plus 10, 130. But now if you come back again to P2, it is going to perform the store operation. It is going to perform this instruction. Store R2 value into D. So final value of D will be updated by 50. Final value of D will be updated by 50 here. So the minimum value we can have here is 50. And you need to find the difference of these two, y minus x. 130 minus 50 will give you what? 80 as the answer. 80 is the correct answer for this question. Is it clear to all of you? If you have any doubt here, please ask. Anyone having any doubt? Is it clear? Okay, yes, 80 is the correct answer. So that's it guys from this class. I hope you really enjoyed this class. This is the link. You can join this Telegram group. This is the link. You can join this Telegram group and you will be getting the PDF of all my YouTube classes. Just after the session I will be posting that. If you have any doubt, ask your doubts here. If you need any guidance, then also through this Telegram group you can message me personally also. I will definitely guide you if you have any doubt regarding your preparation for GATE and other computer science exams. Yes, Anaim, what is your doubt? Could you please explain the minimum again? Carefully see this. If initial value is 100, I want to find minimum value. Now if I add suppose plus here plus 20 plus 10, then I won't be getting the minimum value. In order to find minimum value, I have to execute that process which is performing subtraction. So 100 minus 50 I have done, but just before storing the value of general purpose register after updating 50, before just about to store the value of R2 back to D, I preempted that process. Okay, I preempted that process. Now still the value of D is 100 because R2 value is not updated to D. Now I can execute P1 completely. 100 plus 20, 120, 120, then P3 plus 10, 130. Then P3 is done, P1 is done completely. Now come back to P2. it is going to execute this statement, store R2 comma D. That means the final value of general purpose register, it is going to store into the D value, which is 50 here. So it will update the value by 50. This is going to be the minimum value here. This is going to be the minimum value here. That is why 130 minus 50 will give you 80 as the final answer. I hope now it is clear to you, Anayam. Okay, so that's it guys. You can join this Telegram group. Just search in the Telegram and you will be getting the PDFs there. Don't forget to subscribe to BYJU'S Exam Prep YouTube channel. Also press the bell icon so that you get all the notifications of my classes and other computer science faculties also. So I will see you on 20th. But before that, we will be, yes, Shreya lecture is over. I think you have joined late. But don't worry, you can rewatch it again. And we have covered reader-writer problem, classical problem today and its solution and some questions, previous year questions based on that also, and some other questions. Fine. So yes. So one more thing, as your GATE result, thank you so much. As your GATE result will be announced maybe midnight or tomorrow, the BYJU'S exam prep team will be conducting the post-GATE counseling programs. I mean the session, multiple sessions we are going to conduct on YouTube. So don't miss that. We will be guiding you throughout so that you can get the best college possible based on your GATE score. Okay. So don't forget to join those sessions. I will be sharing the links of those sessions in my Telegram group also. So thank you all of you, and do subscribe so that you get all the notifications. Thank you all of you. Good night. Take care and bye-bye. Thank you all.